Hello, my name is Jaideep Joshi from Stellus Technologies. I'm here to talk about the role of high-performance storage in life sciences. Enhancements in speed and accuracy, coupled with reduction of costs in technologies such as next-generation sequencing and high-speed microscopy, have made it possible for a variety of organizations to deploy these techniques at scale. Let's start with step one, data ingest. Sequencers and electronic microscopes routinely produce multiple terabytes of data on a daily basis. This raw data needs to be stored in a scalable storage system that can grow as the number of these experiments and consequently the amount of this data grows. It is normal for organizations to do some kind of basic data prep, whereby some data transformation occurs to get the data in what you would consider an analysis-ready state. This could be simple things like format changes or alignment of images, etc. Once you have data in an analysis-ready state, researchers often use a variety of tools and toolkits. They could be open source, they could be commercial tools to create fairly elaborate pipelines. This could be multi-step pipelines. Some are close to 20, 25 steps. There could be quality control steps added to them. And these pipelines are essentially created and then submitted to what you would consider a compute complex. Compute complexes can be your legacy HPC clusters. They could be even newer machines with GPUs and FPGAs. Right? So with the addition of GPUs and FPGAs and multi-core CPUs, these compute complexes are now fairly capable of doing a lot of heavy lifting when it comes to analysis. So these workflows are now what you would consider to be compute constraint in the past are now becoming more and more I/O constraint. All the more reason why you need a high-performance storage system that can deliver data access, certainly high throughputs at low latency. These compute complexes then will read these large data sets, or what you would consider large data files, and then churn out something that is germane to the analysis in the form of some kind of result. Researchers often will not take that result at face value. They will do some kind of assessment of that result or quality control to make sure that it meets their criteria. If it doesn't meet the criteria, steps 1 through 4 are performed again. In a lot of cases, 1 through 4 could take up tens of hours at a time. It could take up days. In certain cases, it could take up weeks. So anything and everything that can be done to expedite this process is often desirable. Certainly a high-performance storage system to take out those storage bottlenecks certainly plays a role in that. Once the result is considered good enough, it is then sent out for downstream analysis. Downstream analysis could be something that is done in-house by these organizations, or it could even be carried out into the cloud. Typically, let's say in the cases of genomic sequencing, you start about 100, 150 gig worth of data from a particular run. By the time you get to the result, which is fairly small, maybe 10, 15 gig worth of data, you create what you would consider data bloat. There are several intermediary files in a variety of format that get created. Customers could create upwards of a terabyte worth of data. Nobody wants to keep that data on a primary storage system, so often customers look for ways to send that data to a low-cost tier, whether on-prem or something like an object storage system in the cloud. It is also very typical to not just look at these experiments in isolation. So organizations often take the actionable insight or the data insight that they have derived from these experiments and try to correlate it with external data sources. These external data sources could be electronic health records, they could be EMR data, it could be public health data. That gives the organizations the chance to do some ML and AI related activities to create more of a 360-degree picture, or to get a complete or overall view of the problem they're trying to solve. I urge you to visit Stellus.com to see how the Stellus Next System 1 can benefit your organization, and especially in the case of life sciences, when you're dealing with large data sets related to genomics, cryo-EM, and ML and AI. Thank you.